All right, here we go on 8.4 graphing logs. I'm on 23 in the notes if you have the packet. If you don't have the packet, just pull out a scratch paper and take some notes. So if you look at the, I'll explain these, they're already filled out, right? But all I did was I just replaced the X with the input and got my output. You can see boxed in there in red. And then on this one, I did the exact same, but you can see the X and Y flipped. And this is called an inverse in math. So you can see what happens is we have an exponential, and its inverse is a log, as we've been learning. So this is a little sloppy, so let's redo that part real quick. So if I do 2 to the negative 1, I get 1/2. And then over here, so the X's and Y switch. So log base 2 of 1/2 is asking what's the exponent on 2 to create 1/2, and well, that answer is -1, right? What was the exponent to make 1/2? So you can see the X's and the Y's literally switch as we work with logs and exponent because they're inverses, okay? All right, so the one that I boxed in red on this first table are the outputs, and you can see they're the same as the inputs because they are inverses. Great, so I graphed them. The top is exponential, the bottom is log. So as we graph a log, it is the exact inverse of an exponential. And we're going to use that idea to help us graph these and know what points to plug in and just make it a little bit easier. All right, so let's graph this log because there are some weird things that are happening. So we're just going to graph it just by plugging in these points. So if you, and by the way, we're doing this by hand because there's going to be a no calculator section on the test, so you got to be prepared for that. So if I try to think what exponent on 2 creates -2, well, exponents tell us how many times to multiply the base. So you can't multiply 2 and get a negative, right? 2 times 2, you just can't do it. And so this actually doesn't work. If you remember, we talked about the excluded values, the extraneous solutions. So that just doesn't work, okay? So how many times can we multiply 2 and get -1? Well, you can't do that either. Just some values won't work, and negatives are those. How can you have a base of 2 and get 0? You can't, okay? So this is just kind of a reminder on how you're going to find your asymptote. So if I show you back here, the asymptote for the log was at x is 0, right? Because, well, no matter what you do, it's, in this I just plugged in points and found the graph, and you can see it naturally did that. Like I just put in the points. You see there's points, right, that I just did. So naturally that asymptote is going to happen, and that's based on the argument. We'll talk about that. All right, so as I plug in these points, log base 2 of 1, so what's the exponent on 2 to get 1? That's 0. What's the exponent on 2 to get 2? Replacing the 2 in for the x. Well, that's a 1, okay? So I have 2 points, 1, 0. Yeah, sorry. Okay, 2 points, one at x is 1, y is 0, and the other one at x is 2, y is 1. Now we know it's not a straight line. If it was a straight line, this would be linear, so we need a few more points, so I'm going to plug in a 3. So what's the exponent on 2 to create 3? Well, I can't do that one without a calculator. So you can see not all values are going to work nicely. I'm going to go back and see if 1/2 works. So if I plug in a log base 2 and try to get 1/2, oh yeah, that's -1. So half -1, I know that's going to happen. So I'm going to try 4. Now this does work. If it doesn't work, I wrote error. It does work, but it's a decimal, so I can't do that in my head. But log base 2, so what's the exponent on 2 to create 4? It's 2. So we know I have another point at 4 and 2. And with about 4 points, we can get a general idea of the shape. So I'm going to do that. We could do a few more points, right? I could do 1/4 in there. So log base 2 of 1/4, that is really ugly though. We know that it's negative because it's a fraction, and we know that 2 squared is 4. So at -2 we're at 1/4, which Just go to there. Okay. All right. So that wasn't super efficient. I didn't know what numbers to plug in. I just tried some that was a little chunky. So I'm going to show you a way to kind of speed this up and make it a little bit easier to work with. All right. So what we're going to do is we're first going to find our asymptote. So cross off end behavior on page 26 and write asymptote. Okay, so if you remember, a log, so the base is 2. So we're thinking about how many times 2 multiplies by to create this number, right? So if that number's 4, the answer is going to be 2, because 2 times 2 is 4. So what I just talked about is the argument. And the argument is produced by 2 multiplying over and over and over again, however many times, okay? So the argument is what has the restrictions. And if you remember, the argument must stay greater than 0. Okay? So we're going to minus 1. We know our asymptote is at -1. As you can see there, I already drew it in. So that is how you find your asymptote, and then you know, well, I don't plug in any numbers, you don't plug in -1 and any numbers before that. Okay, so you have a couple options here. You can guess and check. So I usually do start with some fractions. Okay, so we can't use -1, but I'm going to try -1/2. I'm going to try it out. Okay, so that'll be log base 2 of -1/2 plus 1 plus 4. So -1/2 plus 1. So how did I know -1/2? Well, I knew I couldn't do -1 or lower, so I just got something close, okay? -1/2 plus 1 is 1/2. Log base 2 of 1/2, if you remember, is -1. -1 plus 4 is 3. So I know that I'm going to have a point at -1/2 and 3. Okay, now I can't plug in, actually let's stay in red. I can't plug in anything to the left of -1, it's restricted, right? So I'm going to use 0. So if you kind of look, -1/2, 0 is going to be the next one. So log base 2 of 0 plus 1 plus 4, so 0 plus 1 is 1. How many times do I multiply 2 to get a 1? Well, that's 0. Okay? 2 to the what equals 1. 0 plus 1 is 1, right? That's 0. Okay? So we have 0 plus 4, which is 4. So now I'm going to go to 0 and 4. Okay, now I'm going to try a 2. 2 plus 1 is 3. And log base 2 of 3, we kind of already talked about that. So I kind of know that that's not really going to be one that I want to try to think about in my head. Okay? Alright, so no 2. Let's try 3. So 3 plus 1 is 4. That seems like a nice number to work with if we're working with 2, base 2, right? So 3 plus 1 is 4. How many times do I multiply 2 to get 4? Well, that's squared, right? So it's a 2. So 2 plus 4 is 6. So at 3, we're going to be at 6. All right. Okay, I have 3 points. Let's do one more. Okay. So 4 plus 1 is 5. 2 doesn't multiply over and over because 2 times 2 is 4 times 2 is 8. So really the next number that I'm trying to get in there is 8. So that's going to be 7, right? That should be the next one I plug in. 7 plus 1 is 8. So log base 2 of 8. 7 plus 1, right? That's 3. 3 plus 4 is 7. Okay, so now I'm going to go over to 7, and it's going to be at 7. Okay, so I'm going to follow my asymptote, because I didn't want to put in any other fractions. I'm going to follow my asymptote nice and tight, and then follow it out, and I have my log graph. All right, so kind of think about this. What did I do? I just had to be careful about what numbers I plugged in. And if you take a higher level math course, you'll have different bases and you'll learn a few different strategies. But because we're working with base 2, I basically needed to know, and I could have gone, had that become -1, right? Not in this case though, right? My input couldn't become -1. But if you kind of think about the pattern, let's look at it. 2 to the -2 is 1/4. 2 to the -1 is 1/2. 2 to the 0 is 1. 2 to the 1/2. Ooh, let's not do 1/2. 2 to the 1 is 2. 2 squared is 4. And then we did get into 2 cubed, right? Just to give ourselves enough points. 2 to the -3 will be 1/8. So if you just kind of focus on these numbers, right? So these, remember the x's and the y's switch. So in this case, they were the outputs, but then when we do a log, they're going to become the inputs. So that's kind of the goal with the x plus 1, these numbers here. Okay, so we're going to talk about domain and range. But before we do that, just for right now, let's ignore that 2 because it's going to complicate things. And I don't actually have any vertical stretches. That's what that causes, so don't worry about that. So let's look at this one. Okay, so first off, our asymptote. So cross off end behavior, we're going to do the asymptote. So we're going to take the argument and say, yep, you cannot be 0 or negative. So we add 3. That means we have to use things greater than 3. Because if we plug in a 3, 3 minus 3 is 0. If we plug in a 2, 2 minus 3 is -1, right? So these are causing problems with the logs argument. So our asymptote is actually at x equals 3. So we have our asymptote, and that kind of helps us know what to plug in, okay? And so I usually just take my asymptote and I go 1/2. So I'm going to plug in 3.5. So if I plug in 3.5 there, 3.5 minus 3, I'm going to have log base 2 of 1/2, which is, if you look back, right, how did I get 1/2? Ooh, the exponent was -1, okay? So that's going to be -1, and then I'm going to minus 5, and I'm going to get a -6. Sweet, okay? Now I'm going to just kind of jump up from there to the next whole number. I'm going to do 4 minus 3, which is 1. So it'll be log base 2 of 1, which is 0. 0 minus 5 is -5. So I'm going to plot those 2 points. So at 3.5, I'm at -6. 3.5, -6. At 4, I'm at -5. And then let's plug in a 5. Okay, 5 minus 3 is 2. So log base 2 of 2 is 1. 1 minus 5 is -4. So 3.5, 4, 5, I'm at -4. Okay, this is where it gets a little bit tricky, right? Because 6 minus 3 is 3. We can't multiply 2 over and over to get 3. So then try 7, right? 7 minus 3 is 4, that's going to work. So the next number I'll plug in is a 7. Log base 2, 7 minus 3 is 4. So log base 2 of 4 is 2. 2 minus 5 is -3. So at 7, we're going to hit -3. Now notice the graph, yeah, we skipped x values, but the graph is decimals, right? It's just decimals there. And so that's why we have to skip those x values. Okay? All right. So you should be good with about 4 points to be able to see the shape. So what is my domain? Domain is the x values. So if you kind of look at the graph, no graph, no graph, no graph, right? So that's not part of the domain. So the domain doesn't start until after the asymptote, right? So there's no x values that give an output until right after 3. So the domain is from 3 to infinity. Now notice those arrows are going up and down forever, so the outputs are endless. Negatives, positives, right? Any y value, any output can and will happen. So there's our domain and range. All right, so what did we learn? Well, we got to be careful about our asymptotes, and that's just taking our logs and checking the argument and making sure that that argument, whatever's the input of the log, is greater than 0. And whatever that value is, that becomes our asymptote. Okay, then we learned about our table of values. That helped us. And we're just plugging in and computing the logs and going for it. Okay? And that's kind of it. It really is just finding the points and plotting them. So, here's the deal. We accidentally made your homework a little bit more advanced than it needs to be. So I'm going to post a separate homework if you're doing this. But I wanted to do one more example, because on the homework you will see, on the homework in Canvas, or if you show up to class, you will see a log base 3. So I want to talk about that. Okay, so as we're doing our table of values. Okay, so we have our x and our y, our table of values. So first off, we're going to check our asymptote, and we're going to notice that it is at, well, x plus 1 needs to be greater than 0, right? So we better be greater than -1. There's our asymptote. So I'm not going to plug anything in until after -1. Now -1/2, usually you're just, like I said, you're going to kind of jump a half there, but here's the problem. 2 and 3 aren't really multiples of each other, and 3 needs to multiply over and over and over again. So what I'm actually going to use is -2/3, okay? And this is why. I'm going to think of the exponents of 3. 3 to the -2 produces 1/9. Wow. Sorry, I was thinking 1/9 and then my hand went crazy. 3 to the -2 is 1/9. 3 to the -1 is 1/3. 3 to the 0 is 1. 3 to the 1 is 3. 3 squared is 9. And then 3 cubed is 27, just to give us a few more numbers, right? So kind of, that's what's going to happen when we start using these exponents. So if x could have, like if we could make this to be -1, which we can, right? If we can make this to be 1/3, the output will be -1. So that's kind of our goal. Make it be 1/3. So I just kind of thought about that. How could I make that 1/3? So -2/3, right? -2/3 plus 1 actually produces 1/3. So 1 minus 2/3, right? So -2/3 plus 1, we get 1/3 inside there. So log base 3 of 1/3 when we replace the x with -2/3 plus 4. So how does 3 become 1/3? Well, if the exponent's -1. So we have -1 plus 4, which is 3. All right, so input, output. So I'm going to guess where -2/3 would be, a little bit past half, and then I'm going to go up to 3. Okay, next number I'm kind of shooting for is this 1, right? I want to get 1. So how am I going to get 1, right? How am I going to do that? So I have to think, how do I get that value? So, 0 plus 1 is 1. So my input will be 0. So log base 3, 0 plus 1 is 1. So 3 to what produces 1? Oh, I forgot. Sorry. 3 to the 0, right? Okay, so 0 plus 1 is 1. But the answer to this is 0. 0 plus 4 is 4. So then at 0, I'm going to be at 4. Great. Then I'm going to plug in. If I plug in a 1, I can't plug in a 1 because 1 plus 1, if I plug in a 1 up here, 1 plus 1 is 2, but the next goal is to get a 3. So I'm going to plug in a 2. So log 3, 2 plus 1 is 3, plus 4. So this, log 3 of 3 is 1, 1 plus 4 is 5. So at 2, we're at 5. Okay, now I can't plug in a 3 because 3 plus 1 is 4. The next goal is 9. That means I'm going to have to plug in an 8, right? 8 plus 1 is 9. Okay, so now I have log base 3 of 9 plus 4. And so that answer is a 2. 2 plus 4 is 6. Okay, so at 8, I'm at 6. And that seems like a pretty good stopping point to me. Okay, all right. And put your arrows down. Okay, so I actually did my tables of values up here, but that's okay. All right, so what do we got going on? Well, our domain is -1 to infinity. Ooh, that's the worst infinity ever. And then our range is -infinity to infinity because it goes up and down forever. Okay, let's see. Do I have any other base 3? Yeah, I do over here. So, hey, if you're feeling good, hop onto the homework. It's in Canvas. If you're not, keep watching. Okay, so first I'm going to find my asymptote. I know it's going to be at -2 because x plus 2 has to be greater than 0. So I can't plug in anything. I can't plug in a -2 or anything below that. So there's my asymptote. Now I'm going to find my table of values. Okay, so I can't plug in a -2, but if I plug in a negative, now remember, I'm working with 3's, right? The base is 3. So it's always asking what was the exponent to get the argument. What exponent, right? So for example, if I have log base 3 of 9, what was the exponent to make 3 become 9? A 2. So you got to get your mind in log mode. Okay, so let's see. I'm going to first start with, and if you remember, we talked about this, 1/9 or 1/3. That's kind of the end goal. I want to make this 1/9 or 1/3. So what I'm going to do is I'm going to just subtract 1 and 8/9. Okay? So -1 and 8/9 is going to be really, really, really close to the asymptote. That's going to be the x value. -1 and 8/9. Now if I plug that into here, and for the x, -1 and 8/9 plus 2, that's going to give me log base 3, and that's going to give me 1/9. So how many times does 3 multiply to make 9? Twice, but it's a fraction, so it's a negative. Okay, so at -1 and 8/9, I am at -2. Okay, great. Now next goal, I'm going to try to get a 1/3 in there. Okay, so I know that if I minus 1 and 2/3, I'll have 1/3 left over. So I'm going to say log 3 of 1/3 because I plugged that sucker in right here. -1 and 2/3 plus 2 leaves me with a positive 1/3, which I wrote. So 3 has an exponent of -1 to create 1/3. So when I'm at -1 and 2/3, -1 and 2/3, I'm at -1. Great. Okay. So I went through 1/9, 1/3. If you remember, let's go back real quick. The next number in the pattern is a 1 that I'm trying to get. Okay, so I want to try to get a 1. I think the only way to do that will be to plug in a -1. Okay, so -1 plus 2 is 1. So log base 3 of 1 equals 0. So at -1, we hit 0. Okay, now the next number is 0, but 0 plus, I can't use a base of 3 to get a 2. So I can't use 0 because 0 plus 2 is 2. Base 3 can't create 2. But if I put a 1 in there, I'm going to get 3. 1 plus 2 is 3. So then I'll have log base 3 of 3. The exponent's 1. 3 to the 1 makes 3. So I'm going to go over to 3. And the output is, oh no, I did 1. Sorry. Went over to 1 and the output is 1. 1 over to 1, output's 1. Okay, 2 won't work, right? Because 2 plus 2 is just 4, and base 3 can't create a 4. 5 plus 2 is 7. Nope. 6. Nah. Okay, I'm going to try a 7. 7 plus 2 is 9. So log base 3 of 9 is 2. So when we plug in a 7, the output's 2. So I'm going to go over to 7, output's 2. I'm going to follow the asymptote, and boom. We have our beautiful log graph. Okay, so the domain. Negative in, no, right? Now we got to be careful. So the graph doesn't produce output until right after -2. Just remember, domain is looking at the x-axis. No graph, boom, and then right there, graph finally starts. So domain is -2 to infinity. Notice it's a bracket because it's not included, and domain is up and down forever. All right, take a look at the homework in Canvas. Email me if you have any questions. Good luck.